Hello everybody. Today I'm very excited. I've got my new battery pack from eBay. It's a 20 cell with a BMS circuit on the side of it, or a battery management circuit on the side of it. I bought it from eBay. It's based around the LG MF1 cell, and it's comprised of 20 of those cells in total. I bought it for $34.99, and I think it's a pretty good deal. But I'm going to review this deal top to bottom, or this battery pack top to bottom, so that you guys know exactly what you're getting when you buy this. So I'll start the review on the actual listing on eBay. And as you can see here, I got it from Alarm Hookup, and I will put links to this stuff in the video description below. And first thing to note is that the listing is somewhat inaccurate. So, well, let's just go through the inaccuracies, okay? First of all, it states that it's a 4.4 amp hour battery pack, and actually it cannot be a 4.4 amp hour battery pack. Why? Because the cell can't produce that kind of energy. So if we look here at the actual specifications from LG for the MF1, you'll see that the nominal charge or milliamp hour capacity is 21.50 milliamp hours, and based on that, then the total amp hour capacity of this cell, of this battery pack, can only be 4.3 amp hours. So you're getting 0.1 amp hour less. Unless they figured out a way of getting 4.4 amp hours out of these cells some other way, because they're not rated to be that high. So the other thing you'll notice is the picture that he shows of the battery pack is different than what I've got here, and that's a good thing actually. And he does state in the in the listing that it's not. That the picture will not be what you're getting. You're going to get something that looks like this, with a BMS mounted on the side of the battery pack, which, as far as I'm concerned, is a way better thing, because it's much easier to have it mounted on the side, and allows me to disconnect the BMS if I want to, and basically test the cells individually through the the BMS wire. So I'm very happy that it came with the BMS on the side. As it makes it much easier to handle, number one. Number two, if you want to take the BMS off the unit, it's much easier to do as well. So happy with that. He does state that in the description for the product, so that's not misleading at all. That's great. So let's go take a look down at the description, and he states again that it's 4.4 amp hours here, but it's not. It's 4.3 amp hours, and like I said, unless he's figured out a way of getting more out of it. And it says genuine LG 2200 milliamp hour cells. Again, not. They're 2150 milliamp hour cells. And then he goes on to state more like 2270 or 2310 milliamp hour cells. Well, no, that's not what LG says. LG says they're 2150 cells. So what LG states for this battery, for these cells, is what I take to be, basically the God honest truth. The next inaccuracy in this is that he states that these are rated for a 10 amp continuous, 20 amp max per cell. Inaccurate again. We look at the spec sheet here, and it says the maximum discharge current that these will do is 10 amps, max. I looked all over the spec sheet for a 20 amp spec, not there. So I go with what LG says about the cell. So the rest is pretty well boilerplate. He does state here that most of these have a side mount BMS, and I'm glad I got one with that. And he says you can't beat the deal. It's not a bad deal at all, actually. And I'll show you the breakdown on what he's selling. He's selling them in 20, 60, 100s, 200s, 300s, 1,000, 2,000, and 3,000 cell, what do you call them? Packs or bunches. And I bought the 20, of course, as you can see here, and so that means I paid $1.75 per cell, for what I got, which I think is a good deal. But if you buy more, of course, you get a bulk discount all the way down to $1 a cell at 3,000 cells, for that package. So again, I'll put links to the seller in the video description for you, so that makes it really easy. I will also put a link in the video description for the actual specification sheet from LG about this cell. And I verified actually that I was correct in this, because nicely enough, LG put a picture on the actual spec sheet here showing you what it's supposed to look like, and it's the right color and it's the right number or printing on the side of the cell, and all the cells are the same as this. It's not a mix and match. You get all LG MF1 cells, 18650 cells. So that's great. Next, let's take a look at the physical construction of this battery pack as well as its weight. Let's weigh the battery pack up, see what it weighs. 928 grams, or in ounces, 32.72 ounces. Let's measure it next. Use my calipers here, and we're going to do it in metric and imperial. So in length, 132.41 millimeters, 42 there, or 5.2130 inches. Let's go and get the width on it. Back to metric on the start. 83.77 millimeters, or 3.298 inches. And the thickness is, or height, 2.2 inches. Back to metric. 57.26 or 27 millimeters. So, and that includes the BMS, which is right there, or the battery management circuit. Other thing I wanted to note here is that you see all this, let's turn it that way, maybe you get a better view of it. All this junk on this piece of tape here, that's styrofoam packaging and a little bit of cardboard that's stuck to this because they didn't put the actual battery into a plastic bag before they put it in the shipping box. So note to the seller, do us all a favor, wrap it with some cellophane or something, and save us having to pull all that styrofoam packing off of the tape. So that's it for the weight and the actual size of it. Again, let's take a closer look here at the BMS and how that looks like, or the battery management system. And basically, you'll see here, it's just stuck to the side of the battery package right there. You can see it. And here's the connector for it. And that connector was, as you can see, a little yellow glue on there. It was glued to it so that it wouldn't come off. I used a utility knife, and I just did very carefully cut the glue off so that I could remove the connector to the BMS. And there's the connector from the BMS removed. You can see the glue on it. So you're gonna have to cut that glue off very carefully, and then you can actually remove the BMS from the connector from the BMS socket there. And you know, pretty standard stuff on that. Let's go over here. I did crack it in half. I haven't fully disassembled it. I may disassemble it here in the future, but I'll show you what I found so far on this thing. This is, by the way, this is paper tape on here, paper adhesive, I should say. And you peel it up a little bit, you can see that underneath we've got all LG batteries, and they do go all the way around. I don't want to pull it much further than that because I'm pulling on the wires. They are the MF1s, and I'm very happy about that. They're all the same. So I'm just going to put that right back together here for now, because I want to test out every battery in this thing so you guys know what the capacity is in the brand new state that it's supposed to be in when I get it. So next we're going to I'm going to make sure that every one of these batteries is fully charged to 4.20 volts as per spec. Actually, before we take it and start balancing the actual battery pack, let's go a little further here. I want to show you some more on the physical attributes. This is the connector on the end is an XT60. Let's see if I can. There we go. It's an XT60 connector. So if you need to know what you can connect directly to it with, that's it. Let's zoom back out a little bit and let's do a little bit more physical on this. I did crack open the BMS, so I'll show you that next. I'll take that piece of tape off of there. And all of this stuff is taped together with this heavy duty paper tape. I don't know what kind it is, but it's pretty good. All right, so there's the BMS totally exposed. Let me zoom in on it for you. There's what you got. And I do note that we've got a connection from the negative to the C negative, and from the negative on the battery to the, what is this? Let me see if I can read it. B negative on the actual BMS. There is one more connection, the P connection, and from what I read online, you can use the P connection to connect to the negative power, and therefore you'll have well, negative power, I should say, negative load. So if you had a motor you want to connect it to, you could connect it here, and you could charge and drain at the same time. But I don't know if that's possible on this BMS. I'm only guessing that it's possible, but I may actually test that, put a load on that while I'm charging it, see if you can actually do that. And as you can see, here's the circuitry. I think these are MOSFETs, and you know, basically that's your BMS. Let's turn it over so you can see what's on the back, and you can actually see the model number of this BMS on the back. So, and again, stuck together. Let me flip it. I don't like doing this too much because it's putting a strain on all the cables, but here we are. And that's the rear of the BMS. And you can see there's a whole bunch of spaces here where there's nothing. Where there's circuitry where you could put circuitry, but there's nothing there. And the same on the front. You'll notice here that there's a blank spot here, so it could have actually been, you know, I'm sure it could have been made into a, this is a 10S 2P BMS right now. Actually, it's just a 10S BMS. You can see here where there's another circuit missing, and also a bunch of contacts here. So you probably could have added another 1, 2, 3 connections to it and made it into a 13 BMS. But anyways, that's what we have here on the circuit board. And on the back, it does have a part number, so I'll zoom in on that for you guys, and you guys can see what that is, so you can look it up. I looked it up on Google and did find a manufacturer for it, but it didn't have much of the specs on it. So there we go. It is, all right, that's as zoomed in as I can get. I'll read it out to you. It is it's HY-HZQ-1002A_V01, and then the number on the side is 201411021. Okay, so those are the numbers. I'll put them in the video description for you if you can't read them off the video, and go on from there. So let's go back to the battery pack here. Again, you can see the nice batteries from LG. Now, one more thing about LG that they do is which is kind of neat, and they showed it in the PDF that you know, describes the actual video. They don't have a standard top collar here. They have almost like a proprietary top collar, and I don't know if you can see that or not, but there's actually 2 grooves in the top collar of the actual battery. I'll get another one here so you guys can see the difference. Something that's not an LG. Here's another LG, so you can see with a different color. But you can see again, they do this, they give it 2 rings on the top, not just one. So you can see those 2 rings there on those cells. So that you know, verifies to me that they're genuine. A fake cell or a different cell. Here's a non-LG battery, and you can see here that it only has one little notch on the positive end of the actual battery. And you see the difference here. There's double notches, and that is what's specified in the actual spec sheet. So beautiful. I know these are genuine. I mean, it's just great to hear that I got genuine LG cells on this thing. So that was the last part of the physical I want to do for now. If I find anything else I want to show you guys, I will. So I'm just going to put the BMS back on here like that, and it just sticks back onto the tape, and then I'm just closing it up and taping it back closed. So that's it for the physical. And as I said, I'm going to show you how to balance. You can manually balance this battery pack if you're using something like a Turnigy you know, you can actually use something like this charger here from Turnigy. This is the AccuCell 6, but any LiPo charger will do. You can manually connect to this connector and actually balance every one of these cells, well, every pair of these cells, and get a proper voltage on all of them across the whole battery pack. And I'm going to go into the actual physical, well, circuit construction of this battery pack next, so you can see what you need to do the balancing, and then I'll show you how I balanced it. So here we have a diagram of what this cell is actually configured, what this battery pack is actually configured like. And we have the BMS here in the top left-hand corner. It's connected exactly the same way that the BMS is that I got from eBay. You've got the negative coming from the charger or the load, depending on what you have here. And it's going to C on the BMS, the C negative, and then from there it goes to the B negative off to the individual cells or the battery pack itself. And 10S means that there's 10 cells or batteries connected in series, and 2P means that there's 2 cells in parallel connected. So here's what we have. We have 10 sets of 2 cells connected in parallel. So each one of these cells is an 18650, one of those LG MF1s, connected in parallel, and then daisy chained off in series to make a 36 volt pack. So that's what we have with this battery pack. Plus we have the BMS circuitry, which I'll show you that next here. We'll go over here. And again, we've got everything connected the same way, but I've actually color coded this correctly. It's exact same color code as you'll see on the battery pack itself, at least on mine anyway. And you can see that the BMS connects to each pair of these S cells and controls each one of those individually. So really, it controls 2 cells at a time. So at this point, what you can do, if you disconnect this connector here, let me do a little drawing here. There we go. If you disconnect this connector here, you can actually connect your charger to each one of these connections or leads individually. So, and that's what I'm going to do next, and I'll show you how to do it. But basically, what you need to do is you start with the black lead here, and you connect to this point or this point here, and to the first black lead, and then you charge up that cell, and then you just move on in pairs all the way down. So next you would go to connect your negative to the black lead and your positive to this gray lead. Of course, this is disconnected from the BMS when you're doing this, and I'll show you this how I did it and what the values I got from it are. And then you just keep going down the line until you do all 10 in a row. So though that might be a little big here and a little hard to show, I'll show it to you in the actual battery pack itself so you can see how that's done and what those values are. I'm not going to show you the individual charging because I've already done the balanced charging, but basically what balanced charging means is that you're going to take each one of these S series of parallel cells here and charge them individually and get them up to whatever voltage you wish to get them to. In my case, it was 4.2 volts. And basically, you're going to go across each one till you get them all up to 4.2 volts. And I've already done that. So next, I'm going to discharge them all and test them all and see what the actual capacity of these dual packs are. And that should, when I divide it by 2, should give me the individual milliamp hours per each cell. So we're going to do that next. I'll show you how to physically connect to it and do exactly what I did, which is balance charge it. And then I'm going to discharge each one of these cells in the same, well, actually in a reverse manner, and actually give you the values. Okay, like I stated, this is a 10S 2P battery pack. So we've got 10 battery cell packs of 2 18650 LG MF1 cells, and basically here's what I did to actually discharge each one of these cells individually, and also this is the exact same procedure you could use to balance charge the entire pack, so that every cell pack in the actual battery pack has the same voltage. So basically that's what I did to discharge and test this unit. I took each cell pack to 4.2 volts and discharged it from 4.2 volts down to 2.75 volts to get these results. So let's go over here on how I connected it all. Now S1, and you'll see here that there's a black lead. That's the one I'm calling S1. So I started from the black lead and worked my way all the way to the top here. And the first cell pack is the S1, and it's connected here on the first connection on the connector, as you see here. Let's see, let's do a little drawing here. All right, so here you can see where I got it connected there. And on the negative side, I've got it connected to the negative lead from the BMS to the battery pack. That's exactly where it should be. And as you can see, I have my leads correctly actually labeled. And you can see that I got on the first cell pack, I got 29 milliamp hours per cell, or a total of 44.58. There are 2 cells there, so you just divide it by 2. And excellent result. Actually higher than what the pack states you should get. You should actually get 2150 on a perfect discharge. So a little bonus there. And also note that I only took them down to 2.75 volts. Most lithium ion cells actually go to 2.5 volts. So I don't know why these are rated this way, but maybe you can safely go down to 2.5 volts. But the specifications say 2.75 volts, so that's where I stopped. So that's on the cell pack 1, the results there. And then we move on to cell pack 2, and you'll notice that I disconnected the negative lead from the negative portion of the battery pack and moved it to the pin 1 here on this connector. So now the negative is on pin 1 where it used to be the positive on pin 1, as you see here. And you can see on pin 2 that I have the positive there, testing the cell pack number 2. So, you know, basically what you got to do is that all the way across the cell pack till you get, you know, all the way across all the pins and get these results. So you can see here on cell pack 2 that I got 2203 milliamp hours per cell. And again, you can see as I move down that I move the pins along, and I've got all the different results listed here. So if you want to see how to balance these packs, manually balance these battery packs, you disconnect the BMS connector as I did here, and you connect the leads from your LiPo charger as I do here. Just follow this and you should be fine all the way up. These are solid core wires here, and the only thing I caution on in doing that is that if you wiggle them too much, they will break inside the connection. Not hard to get them out, but just be careful with that, and you should be fine. So these are all the results for the first the first 6 cell packs. We go on to the next picture. Let's go here. There we go. And we've got the last 4 cell packs and their connections. You know, the way I did it, like I said, and we've seen more or less very similar results. I did get one here at 4513, which gave me 2257 milliamp hours per cell. Again, excellent results. Very happy with my battery purchase at this point, especially you know, from the price that I paid, which I believe was $1.75 a cell. Now that we know the capacities of the cells on this battery pack, the next thing I want to test is the BMS, or what is called the battery management system, and that's that circuit that's taped to the side of the battery pack. Just so you know, you may not even know what a BMS is, but what a BMS does in a basic term, or a basic BMS does, is it just protects the battery pack from overcharging, over discharging, and short circuit. That's a basic BMS. Now, a more advanced BMS will have what they call a balancing function. And what the balancing function does is it gives you the ability to keep all the cell packs inside the battery pack basically at an even voltage or an even charge. I don't know what the specifics of this battery pack are because I didn't get them from the seller on eBay. They didn't state whether it was a balancing battery pack BMS or not. And I couldn't find any specifics on it on the internet. So what I'm going to do is basically test it to see if it has a balancing function. Now on the screen here, you'll see that I have two circuits for balancing a battery pack. And basically you have a type A and a type B. The type A uses the charge cycle to balance the battery pack and keep all the cells more or less even in charge. And the type B uses the discharge cycle to balance the battery pack and keep all the cells basically even using the discharge cycle. So I don't know which one of these I have. I don't even know if I have a balancing BMS. So I'm going to purposely test it. I've unbalanced the battery pack by taking the S5 battery pack down to 3.93 volts, and all the rest of the battery packs or pairs in the cell are at 4.05. So I'll put a link to this document here on the screen in the video description. It's a tutorial on BMSs. It's an excellent tutorial if you're interested in finding out how BMSs work. And you can read that on your own time. But basically what I'm going to do is test the battery pack BMS for balancing by discharging this down 3 volts and testing to see if the cells are still 3% off, which they currently are. Okay, so I'm going to do that next, and I'll get back to you on my results. All right, here's my crazy setup for charging this cell or the battery pack up. I've got a 32 volt, 1.5 amp HP power pack. This is was for a discarded HP printer that I found on the side of the road, so that's great. It's going directly into my MPT 7210A MPPT solar charger controller at 31.44 volts, as you can see there, and that boosted up to 41.5 volts, which is where I have the actual battery charge to. This meter is showing me the voltage coming from the output leads on the actual battery itself or battery pack itself, and this voltage here, the 4.15, is the actual output from the BMS, which is exactly the same currently, which is cool. So now we're going to see what the balance charges are on the actual BMS. So I'm just going to disconnect this connector and connect, and notice how everything changes when I did that. I should disconnect the battery here too. There we go. And now I'm going to just connect to this and see what my voltage is. All right, I've discharged it and recharged the battery pack 6 times now. So it's 3 discharges and 3 charges. Starting at the beginning discharge, I was at a 0.8 volt difference between all the other cells in S5 that I got marked there. And the last 2 discharge and charge cycle, I was at 0.12 volts, 0.13 volts. So it seems that the more I charge and discharge the battery pack, the more the unbalance between the S5 battery pack inside this and the rest of the batteries in here, or the rest of the cells in here, gets. So I'd have to say that it's not charging or balancing the battery pack. So I'm thinking that the BMS on this unit is just a protection circuit, not a balancing circuit. So if you want this battery pack to balance, I would say buy yourself a balancing BMS circuit for it. Otherwise, understand that it's not. You can manually balance it, like I said, by connecting to all these connections using a charger of some type, and then charging each cell pack up to 4.2 volts if you wish. That's the highest that you should charge them. But again, all my tests show that. So let me just show you what I got here at the end. I've got it fully charged, well, not fully charged, up to 41.5 volts here. So I'll show you what S4 is doing for a voltage. 4.17, and all the other actual cells are doing that, except for the S5, which I intentionally unbalanced. Let me plug into that, and it's at 4.04. That's a difference of 3.12%. I started with a difference of 2.96, so it got a little worse, but the last 2 cycles, it actually stayed exactly the same. So it's not getting any better. So I would say, again, this is not a balancing circuit. So It's a protection circuit. Next, I'm not sure what I'm going to do. I'm going to probably do a full discharge and charge and see how much, a full discharge. It's already fully charged. And see how much milliamp hours I get out of it, or amp hours I get out of it. Other than that, after that, I'll wrap it all up and, we'll finish up the video. All right, I was going to do the discharge test, but before I do the discharge test, I figured that I'm going to balance the battery pack, which I did. They're all the cells in this battery pack are now at 4.17 volts, and that's indicated over here on this meter that's connected to the actual battery pack here and to the positive terminal from the actual charger. So we're at 4.1 volts in the battery pack. The output right now is 4.12 volts. So, there's a bit of a discrepancy there. I'm sure that's the BMS doing some sort of work there. But I'm going to show you what happens when I try and put 43 volts into it, okay? Let's start the process here. All right, you can see that the charger is now at 43.02 volts. My line input says 4298, very close between the two. There's a bit of a discrepancy between the two of them, but the meter at the input says 43.1 volts, but the meter at the battery says 41.7 volts. So that's almost what, 2 volts? What's it going to be? 1.3 volts difference. Yeah. And it's a little bit of a change there. So I think the BMS is actually protecting the battery pack. So I'm going to go higher. I'm going to go to 45 and see if it makes any difference. By the way, this is kind of scary because if it doesn't protect it, I'm going to damage the battery pack. But this is part of the testing, right? All right, setting it to 45. Ready to go. Let's see what happens. My overvoltage protection. Sorry, let's fix that. All right, there we go. So now we got 45 volts into it. Still 41.7 volts at the battery. So here, this input that comes from the BMS to the batteries is only showing 41.7. So I think the BMS is limiting the voltage going into the battery at this moment. I'll leave it running for a little bit, see if this changes at all, and I'll get back to you, but I think it's protecting it at 41.7. Okay, I've been cranking it for about 20 minutes now at 45 volts, and as you can see, 41.1 volts, 45.1 volts, no problem. But the BMS is only showing here on the output from the BMS 41.7. So the BMS is actually protecting it. I'm going to take it up a little higher and see what happens. See if it actually stops it or cuts the circuit. But I don't think it will. But currently at 45 volts, it's not going any higher. So let's take it up and then I'll continue from there. Let's see. Stop it and let's set it to 50. All right, we're at 50. There we go, up to 50 volts. Still no change over here. So, yeah, the BMS is actually doing its job here. I don't want to overdo it too much. I mean, you should never really be putting 50 volts into this thing anyway. Maximum should be 42, really. So, I'm going to stop it here, but obviously, 50 volts, 41.7 at the battery. This thing's stopping the circuit, stopping the extra voltage. So, great. It protects it from overcharging. Beautiful to see. Like I said, you don't have to have this kind of rig to actually charge this battery. You can buy a $15, $20 battery charger from eBay, and I will put a link to all this stuff in the video description below for you guys. But you can buy a battery charger for one of these packs for about 15, 20 bucks on eBay. So next, we've got it fully charged. Obviously, it's not going to go any bigger than that or higher than that. So I'm going to discharge it and see what values I get from it from milliamp hours and report back to you. All right, I'm going to apologize for the poor lighting currently. because I'm going to be using the 2 lights that normally light up my workbench as a load on this whole battery setup I have here. Okay, so 2 meters are to measure the voltage coming out of the battery and out of the BMS, and the other one is from the actual battery charge itself down here. What I'm going to do is feed this power through my DC voltage meter here, the VAC 1030A, and then it's going to go from there to my adjustable voltage regulator down here. This is a U5S2, and it's going to take it from from the 42 volts that it's at right now, or 41.7, down to 12, and then from 12 over to my DC inverter here, which is a 12 volt DC inverter, and then I'm going to be powering 2 23 watt bulbs with it, which will brighten everything up. And I'm also going to charge my USB device, which is something I'm going to be using as a timer. It has 3% battery capability right now, so it's seriously discharged, but I'm going to plug the USB into the back of this inverter. So let's just start all this stuff running. And I will do a time lapse so we see exactly when this stops working. By the way, well, let's just put it together here. And the actual DC voltmeter has a low voltage protection, so I've got it set up so that when it reaches 27 something, I think, let me check, 27.8, it will stop. So there, I just turned it on. I'm gonna stop it right now. It's off. So we're ready to start this process up, and what we're going to do is turn this DC voltage meter on. It's going to feed the 12 volts into the inverter, and then that's going to turn into 120 and light up both my lights. And I'm going to plug the USB in there, and after all that is done, I will time lapse it so we see how long it lasts, and then I'll give you the results. So let's do that. All right, got the 41, got the 12 volts down here. That means we can turn on the inverter. Let's do that. And we have lights, and the 2 lights are 23 watts each. They're fluorescent bulbs, the curly type, if you know what I mean. And everything's starting to discharge at this point. I'm going to plug in my USB, my tablet, which is going to be, I'm going to use as a timer here, and we'll see how long this lasts. So far so good. All right, we're charging and we're timing right there. Beautiful. Okay, so I'm going to time lapse this process and we'll see what we get. I want to explain that last time-lapse segment a little bit. The total time for the discharge was 2 hours 32 minutes 15 seconds, and that was with 2 23 watt bulbs, 110 20 volt bulbs hooked into a 1,000 watt inverter, and pretty impressive. You know, that's a pretty long time to run a couple of lights on that little battery pack. And my results were basically the cutoff point was 27.8 volts, and I show here 28.61 on the zoom in, but that's because the battery recovers a little bit after it cuts off. And you can see here that I was running about 1.97 amps at discharge rate, so that's pretty good. And but like I said, my low voltage protection kicked in and shut it off at 2 hours 32 minutes 15 seconds. Now, pretty impressive number here. I don't know if you can read it here or not, but it's 3.872 amp hours, or 3,872 amp hours to that point. But to be fair, the actual 1000-watt inverter was kicking up way higher on amperage, because once it has a cooling fan in it, and once the cooling fan kicked in, it went from 28 volts down to, to the cutoff point like almost instantaneously. So in the next segment, I'm going to test the battery down even further, but with a very low amperage load, down below I think it's 0.2 amps, and I'll show you that in the next segment, and show you what my actual final amp hour rating on this battery cell is. But at high amperages, it'll be cutting off, around 3.872 amp hours. Now, I'm also going to test it and show you what the cutoff that the BMS allows you to discharge it to. Yes, there is a lower voltage protection on the BMS. So the BMS has an upper voltage protection and a lower voltage protection, and I'll show you what both of what the lower one is next. Okay, let's test the lower voltage cutoff point or protection point from the BMS. Also note here that I've done a full discharge again this time, and I got 4.34 amps, 4.341 amp hours, which is basically perfect. Exactly what you should be getting out of this battery pack. Pretty good. So let's just start this process up. Right, this first cutoff, I'll do it one more time. I'll just reset it, and the way you reset it is by disconnecting the power from the battery. So there you saw how it just turns off, goes down to 1.81 volts, and it's just done. Basically, it's shut down. I'll slow that down to show you exactly what the cutoff point was, but it's pretty well 2.78 or something, or 27.8 something, which is higher than the cutoff by the manufacturer of 2.75 volts for each cell. So at 27.8, we're still safe on that, on every cell in that battery pack, which is really nice. So that's it on the low cutoff point. I'm going to fully charge the battery now and see what the upper cutoff point is. I've charged the battery pack overnight, and I've got it up to 42 volts on the battery side. So this is the actual voltage on the batteries themselves, without the BMS, before the BMS. This is a voltage on the output from the BMS on the battery pack. We're at 41.5 on that. So that BMS is doing something. It looks like it's cut down the voltage by 0.5 volts. You don't want to go over 42 volts because, divided by 10, which is how many cell packs is in this battery pack, that makes each cell pack be at 4.2 volts. And that's the max that LG says those cells should go up. So right now what I'm going to do is charge it up to, let's say, 43 volts and see if it goes any higher on this side or that side, and see how the protection circuit on this works. So we'll start at 43 and work our way up from that. All right, I was running 43.1 volts there for 15 minutes, and nothing's changed. Still 4.1 volts on the output from the battery pack, so after the BMS, and internally on the battery pack itself, still 42.0. So 43 volts is obviously over the cutoff of the actual battery pack. So I'm going to take it down to 42.5, try again for 10 minutes, see if there's anything makes any difference there, and I'll keep decreasing it all the way down to 42 volts and see if there's a difference. But so far it looks like the cutoff is 42 volts, which is perfect. Well, as you can see there, I had it on 42.5 or so, and basically I've had it there for 20 minutes 35 seconds and nothing has changed. The amp hours are still 0, the watt hours are still 0, everything stayed at 0 basically, and it's on right now, so there is a connection there. So the battery pack is not accepting any more charge at 42.5, and we're still at 42 volts on the battery side and 41.5 on the output from the BMS. So I'll try it even a little lower. Let's try 42.2 and see what we get. Once again, almost 40.3 volts here. Let's pump that up again. And you'll notice again, no difference in the amperage and wattage hours. So 41.5 here, 42.0 there. Now we're 42.28, but it doesn't matter. 2.9. It's not increasing here on the battery side. So the BMS is stopping any input to charge this system at this point. So 4.3, 42.29 is not enough, or 42.3, not enough to trigger any more charging. So I'm going to assume the cutoff is 42 volts, and that's perfect. Okay, that's all the numbers for this battery pack that I could decipher. I think it's a great value. I'm going to put a link to it, to this 36 volt LG battery pack. I'm going to put a link to it in the video description below, and you can go get it from the same seller I bought it from on eBay. I will also put a link to all the equipment and hardware I used in this video as well in the video description below, so you can check that out on the, as you go. All around, if you're a battery harvester, or you need a 36 volt battery pack for a hoverboard, let's say a skateboard maybe, or maybe an e-bike project, this is a great value. Even at its smallest package size, which is this one, 20 cells, it's $1.75 a cell for 2150 milliamp hour LG MF1 cell. These are genuine. They are, from what I can tell, brand new, and they do deliver exactly what they say they're supposed to deliver. So yeah, good option for you. Now, the only weakness I found in this whole battery pack would be the BMS. I don't like that it's not a balancing battery pack, BMS. So I would like to have that feature in my BMS for this battery pack, but not 100% necessary. It's just nice to have. And if you wish to put a balancing battery pack on this, you can buy them for under 10 bucks on eBay. So not really a big issue. And if I may in the future get a balancing battery BMS and actually slap it onto this battery pack, and if I do that, I'll make a video on that. Now, if you have any concerns or any comments or anything else, even if you have some suggestions for new videos, I greatly appreciate that. Just click on the comments below and leave me a comment. I do read them. I do respond to them. So I would appreciate that if you put them there. Okay, that's it for my video on this LG 36 volt battery pack. If you like this video and it helped you out in some way, do me a big favor and click on the like button on the bottom right hand corner and give me a thumbs up. Also, somewhere on the screen here, you should see a picture of me. That's a subscription link. If you click on that, you'll get subscribed to my channel, and also you'll also get a prompt for a bell when you're doing that. The bell is a notification bell, and that will tell you every time I put a new video up right away, and then you can click on the notification to watch it, or you can just watch it at your own leisure. Once again, and like always, I want to thank you for watching and for your time.